In the transformations investigation, what we explored was parabolas that were translated, dilated, and reflected. So just a quick review. We had this parabola here, y equals x take 3 all squared plus 5. We'll note that it's neither dilated or reflected because that's a 1 in that spot, but it's translated 3 to the right and 5 units up. Okay, so knowing that should actually help us sketch some parabolas here. So let's actually sketch up this one. So let's draw up our Cartesian plane, and again, I recommend you guys rule that up. And note that this parabola here moves 3 units to the right and 2 units down. So let's do that. We're going to go 3 to the right. So I'm going to put the 3 there, and 2 units down there. There's our turning point. Okay, from this point on, what we'll need to include is the x-intercepts where it's appropriate and the y-intercepts. Okay, so let's get the y-intercept. So we'll note that the y-intercept occurs when x is equal to 0. So let's do that. So we're going to go y equals, so 0 take 3 is negative 3, negative 3 squared is 9, 9 take 2 is 7. So our y-intercept is 0, 7. X-intercept, let's pop that in. So do we need to do that actually? Turning point, y-intercept. So all we want to do at this stage is turning point and y-intercept. Okay, so that's what we'll concentrate on. So here's negative, here's 2, 4, 6, so 7 is going to be somewhere up here. Right, so note that what the parabola is going to do is turn at this point here. So there's the turning point, and it's going to go up to here. Okay, so the parabola will go up to there, turn, and come back here. Now, very important to note that the parabola needs to look symmetrical about the turning point. Okay, so where the turning point is, that's called the axis of symmetry. This actually can be modeled by an equation. That's x is equal to 3. So the equation of the axis of symmetry here is x is equal to 3. Okay, so we've got that. And what we want to do is when we got the y-intercept, we look at the distance from there to the axis of symmetry, and we need to match that distance over to here. We're just going to continue that parabola on because it goes infinitely big for negative x values and infinitely big for positive y values, positive x values. Okay, so let's just check out what that actually looks like on the calculator. So we'll go to graph and table, and x take 2, x take 3, all squared take 2. All right, so there it is there. We can see our turning point, 3, negative 2, y-intercept of 7. We don't need to worry about those x-intercepts just at the moment. Okay, this one here. So has it been translated left or right? The answer is no. Okay, what it's got is a reflection. No translation left or right. It has been moved up 4 units. So let's get started. So we'll draw a Cartesian plane. Okay, so we've got a reflection in the x-axis, no translation left or right, but translated 4 units up. So the turning point is going to be there. Okay, so what's going to happen is when it gets reflected, what's going to happen is that the standard parabola that looks like that, when reflected, will look like that. So what this does is it basically grabs it, moves it 4 units up, and then it will look like that. So we can complete our parabola quite easily now. Okay, so our axis of symmetry goes down along the y-axis here, and it has the equation x is equal to 0. And not much else we can really do at this stage. We actually can pop these two x-intercepts in quite easily. So we've got the y-intercept already. The y-intercept is the turning point. So the turning point and the y-intercept are the same thing. Let's go x int when y is equal to 0. 0 equals negative x squared plus 4. And what we're going to do is use some inverse operations. So negative 4 equals negative x squared. Divide both sides by negative 1 means that we've got that. And then what I'm going to do is root both sides, knowing or noticing that when I root both sides, I'm going to get root that, and that is going to be plus or minus. So x is plus or minus 2. So this x-intercept here will be 2, 0, and this one here is going to be negative 2, 0. You could also use dots quite easily on that and then null factor law, but I think inverse operations are the way to go. Right, so there's the set questions on that. Okay, so get stuck into that. The second part of your homework will be to determine the equation in this form here from a parabola. So if you're given the picture, you'll be able to get the equation from the picture. It's basically finding the rule. Okay, so let's have a look at this one here. And each time you do these particular questions, we should just follow the same process each time. Okay, so what we note is that we've got this general form, y equals a, x take h all squared plus k. That's a parabola in turning point form in what we call general form, or general turning point form, I should say. Okay, so what we're going to do is note that the turning point of this one here is going to be y equals a. Now there's no translation, so I'm going to go x plus 0 all squared, and it goes 1 unit up, so plus 1. Remembering that all parabolas start, or the basic parabola starts at 0, 0, and then we consider the movements of the parabola from 0, 0. That's what we've got so far. Now, I don't really need to write this plus 0 in there, but I've done it to sort of make a point. But this is going to be a x squared plus 1. Okay, so x plus 0 is just x, and then we're going to square it. All right, so now to get this a value, which will give us the dilation and reflection if it is there, what we're going to do is sub in another point, and it just so happens that they give us another one here. It's 1, 2. So we're going to say sub 1, 2. So that means when y is 2, x is 1. So a 1 squared plus 1. 2 equals a plus 1, a equals 1. All right, so therefore the rule for this one here is y equals x squared plus 1. All right, let's have a look at this one here. Okay, this is y equals a, x take h all squared plus k. All right, so let's note the turning point. So this parabola here has moved 1 unit to the left and 4 units up. So let's write that as we would. X plus 1 all squared plus 4. Now maybe you're looking at the screen going, oh, but it's 1 to the left, so shouldn't it be negative? No, remember that horizontal translation, that plus 1 there means it's moved 1 unit to the left. Okay. Now some students, what they do is they notice that this parabola here has been reflected, so they stick a negative sign straight away in front of the a. But actually what will happen is we're going to now sub in another point. Here's our point that we're going to put in. So when x is 0, y is 3. So let's pop that one in. 3 equals a, 0 plus 1 all squared plus 4. 3 equals a. That's going to be 1 squared, which is 1 plus 4. Negative 1 equals a. Okay, so the a value will sort itself out with a coordinate point. So it'll tell you whether the a value is negative or positive. Okay, so therefore our equation is y equals negative 1 x plus 1 all squared plus 4. Don't really need to write negative 1 there, just negative would be fine. All right, let's try this one here. All right, so we've got turning point here on the x-axis. So that's going to be y equals a, x take 2 all squared plus 0. Right, and again, you'll note that we don't really need that plus 0, but just sort of putting it into the correct form first of all. They've given us the y-intercept, so we're going to sub 0, 4 in. 4 goes in for y, a negative 2 squared. 4 equals 4a, a equals 1. So our equation is y equals x take 2 all squared. So lots of these a values are coming out as 1 or negative 1, but surely this one's going to behave a little differently. Let's just see what happens. Right, so we've got the turning point at the origin, so I'd write it as y equals a, x take 0 all squared plus 0. Don't need any of those zeros though, so we'll just rewrite it as y equals a, x squared. All right, let's sub in this point here, so that's 5, and a 1 squared is going to be 1, so it's just a. So our equation is y. Okay, so this is obviously a mistake because why do I know? Our A value is positive and we've got an inverted parabola here. So what's wrong with this picture? That's 1. That should be -5. Wow, that's a big mistake, that. All right, so our coordinate point that we're subbing in should be -5 and 1, which means that A equals -5, that's for sure. Therefore, so get rid of that one, and we'll say that Y equals -5 x squared. All right, last one. All right, so question slightly modified from a Year 12 SAC. Okay, so this one, was one that appeared in a Year 12 method SAC. So Mr. Tench is a collector of classic Saab vehicles. He has used his expertise to design a wind tunnel to test the aerodynamic features of the cars in his collection. Cross-section of the 6-meter wide wind tunnel is pictured below. Okay. So Mr. Tench has created a function to model the cross-section of the wind tunnel. If the turning point of the function is here, show that the function to model the cross-section of the wind tunnel is this. Okay. Now, firstly, you don't quite know the function notation, but we can quite easily just replace that with y equals. Okay, so that's what we're going to note. Okay, so how are we going to do this? Well, let's assume that we actually don't know the equation. So with a show that question, reminder that we're not allowed to actually use that to show. Okay, so what I'm going to do is just write down the general form, y equals a, x take h all squared plus k. Now they've told us that the turning point of the function is here. Okay, so we can use that. Okay, that's for sure. So that means that the turning point is 3. Let's note it down. So the turning point is here, and that's going to be 3 and 63 on 20. Notice we use a lot of fractions in Year 12 methods. All right, so it goes 3 to the right. X take 3 all squared and 63 on 20 up. All right, now what we had to do then was get another point, 0, 0 or 6, 0. I think it's a no-brainer. We should get 0, 0. So sub 0, 0. So we're going to go 0 equals. Now when I put that, it's going to be 0. Take 3 is -3. -3 squared is 9. So that's going to be 9a plus 63 on 20. All right. So what I'm going to do is subtract that from both sides. So it's going to be -63 on 20 equals 9a. All right. And now what I'm going to do is -63 on 20 divided by 9. I'm going to divide both sides by 9 equals that, which is -63 on 20 times 1 over 9 equals a. That's going to be a equals -63 over 9 times 20 is 180. Okay, so there's our a value. A is equal to, now let's just go over to the calculator and see what that number is. So that's going to be -63 on 180, and we'll go into decimal. And surprise, surprise, it's this value here. Okay, a is equal to, so we're allowed to actually just write that, -0.35. So they're the same thing. We can use the calculator to do that. Therefore, our function or equation in Year 10, we'll call it, is y equals -0.35 x take 3 all squared plus 63 on 20, which is what we were supposed to show. And a lot of students write as required. Okay, that was what was required to do in the question, so we write as required. You don't really have to write that, but I see it a lot. Okay, so yeah, that's how a show that question works. And notice that I didn't use this equation for anything. Okay, I did use this information given to us. I was allowed to do that, but I had to use this information to show that this was the case. Okay, so I kind of had to pretend like I didn't see this, do all my working out, then once I'd done my working out, confirm that that was that, which was the case as required. All right, so the next lot of work that you've got there is from 7A and 7B as well. Okay, so practice makes perfect on that, girls. Working hard.